Good day, everyone, and thank you for attending my class here today about subway and railway tunneling and underground stations design using the AEC collection. My name is Rad Lazik, and I am a civil engineer and specializing in transportation design, but a lot in technology, general technical consulting around Autodesk software, training, customization, integration, and automation. So some of this class today will be very much about customizing and automating processes. And specifically, we will talk about using custom subassemblies and stock assemblies that you can also customize with Subassembly Composer, as well as some custom families in Revit. The idea is then to automate some processes and specifically addressing the challenge when civil engineering design is used for alignment design and Revit is used for architectural structural design. In our case, we're going to have railway track alignments in Civil 3D, and we're going to have an underground station box, you can call it, typically in a box shape. And then we'll employ some Dynamo scripting, both in Civil 3D and Revit, to coordinate. When I say coordinate, we will synchronize 3D models between Civil 3D and Revit. We will use some latest technology from both software and Dynamo scripting to achieve that. So let's take a look at the model that I have here. This is done as an exploratory study. It is around Los Angeles area on a Ventura Boulevard in the Valley. And over here, I'm just going to switch the map quickly. We have a couple of track alignments. And in the Civil 3D, I've created a corridor for the tunnels. So if you select that corridor and look at that in 3D, you will see that the corridor has a couple of segments in there or regions that are covering different parts of the project. In one segment of it, in one region, we have a full tunnel cross section. And then on the other one, we have a tunnel cross section through the station. I'm going to close this 3D view now, and then we can take a look at a little bit more context. The station from Revit is here presented in 3D. And let's take a look. And they're both working together. In this case, the 3D station model was imported from Revit, and the corridor is naturally from Civil 3D. So the way this was achieved, obviously, the typical cross-section for Civil 3D is that of a tunnel. And so I had to develop a couple of cross-sections, assemblies in Civil 3D, and you can see their details. The main line alignment is running along those tracks on the right-hand side, and then we also use the offset track alignment to control the relationship between the two. At times, they will be connected for structural reasons and logistic and operational reasons, and at times they will run through a station where that synchronization between the station and track alignment needs to occur. So you can see that we have to deal with those. Now, the stock sub-assemblies that come with Civil 3D, not too bad, but you will have to do quite a bit of tweaking and control there. So let me just show you a couple of things there. So they will stock sub-assemblies have a sufficient detail and flexibility. It's easy to fit them to your purpose, but you'll need to do some fine tuning to fit within your projects. One thing they will not have is all the properties that you might need and all the details. So for that reason, we're going to go to Subassembly Composer. With the Subassembly Composer, This is the composer file for those two tunnels. What I like about using the subassembly composer is simply the ability to control my own input parameters. I'm going to show you in this example, we are using some flexible properties. The other one, the one that is my favorite, is the ability to change the diameter for the tunnel structure. Let's say if I want to change the outer structure to 24 feet and the inner structure, let's say to 22 feet. Notice how the structure will update and the display will follow my changes. And now I'm dealing with the tunnels of a larger structure, whereas the track alignment relative to the platform or this emergency maintenance walkway is maintained. Also, the elevation difference between the tunnel center line and the track top of rail center line is also maintained. One other thing that I really enjoy using with is target parameters, using with subassembly composer. So clearly here you can see that I can assign my own names for tunnel center line. So, and then these will later on be used when we assign targets for applying them in the corridor model. I'm going to close this subassembly editor. Actually, before I do that, I'm going to show you another file there. And that file is through the station. So through the station, we have a different situation there. Let it open and we'll wait for it for a couple of moments. Through the station, all I need is the bottom part of the tunnel because the rest of it will be in a station box. However, the platforms still have to be there and obviously the railway tracks. This will later on be taken advantage of when synchronizing the model with the Revit. I'm going to use the alignment details that are passed straight through that marker point there or a reference point, and there will be a straight line that will be then used as a reference. So in Revit, that reference line will be used as a host, and we will host pretty much everything that goes into the station to that reference line. So what will that enable me to do is if I make a change on the alignment for the tunnel, I can use DynamoScript to synchronize that change with a host object, which is a reference line in Revit. And then everything that's referenced from that line will update automatically. So that's pretty much what I wanted to show you today. And I'm going to go into Revit now. For this to be achieved, a couple of simplifications there. First of all, let me open that file now. So first of all, since this is an underground metro line, all the stations are obviously under the existing ground, but all the stations are in a straight segment and where the grade on the profile is basically zero and flat. So that makes it easier because of that geometry, but also still challenging to synchronize the two models. I'm going to go to Revit now just for a moment. I'm going to change this and resize my Revit screen. I'm going to take a look at a couple of custom families. So first of all, I'm starting with a family that holds data for the profile, in this case, the station box that will be swept along reference object. And this is a very simple example. So we're going to simplify completely, but over here in this profile, you can add other details for the floor thickness, for the wall thickness, and the roof thickness, and then sweep that along. Another adaptive component, which is the station. So the station family has, I'm going to just quickly show you here with wireframe. So that station box runs along the same reference line. Now, this reference line is hosting the entire station box. Some arbitrary length here, 10, 50 feet, it doesn't really matter because this reference line will be hosted by the actual alignment start and end point in Revit that will be synchronized, and we keep it updated from Civil 3D. So having done that, I'm going to close this Revit. Maybe I can just touch up on some details here. Clearly, this is using the reference geometry, also the adaptive components. Very simple. Those 2 points are made adaptive. They go from the host plane, reference surface, all the way to the other one, and then they're connected with a reference line, like you can see. Prior to that, I was designing the profile, and the profile is also fully constrained to this reference point. Later on, we make a couple of insertions of that reference point onto the host line, and we control that the profile will be swept from the exact beginning to the exact end of that reference line. I'm going to close this and not save any changes that I might have made right now. All right, so the Revit model, I've actually stripped it down just so you can see the 2 tracks. And looking at the 3D, it basically just has those tracks along the alignment. So let's take a look. How are we going to do that with Dynamo? So I'm going to flip over to my presentation, show you what we're going to do next. So we are going to explore the technology at the conceptual level. And so far, we've looked at the alignment in Civil 3D and how we're going to use that as a host object in Revit. I'm going to now collect the alignment geometry using the Dynamo script in Civil 3D. And I'm going to write that geometry out to a file and then read that file using the Dynamo script in Revit to create the host element in Revit. Then what we're going to do, we're going to play it with it a little bit. I'm going to grab the alignment design and make a change, and then see how that updates the host. What we're going to do then is the dependent elements in Revit will update with the host. So let's grab Civil 3D. In Civil 3D, Dynamo is started from the Manage menu here, and I'm going to go into Dynamo. Open that Dynamo. That will basically collect some data from the drawing and send that over to Civil 3D. Of course, we have to open the Dynamo in the host drawing file, so we're going to do that. And running this script can be manual or automatic. It's probably better to not have it automatic. I'm going to go now to Revit and do the same. Working from my Revit view, here's just a simple site level street view. I'm going to start Dynamo. And I'm going to create a line reading the elements from the Civil 3D drawing file. You can see because my Dynamo script was set to run automatic, the host line is already there. So my custom families are already imported into Dynamo. So I'm just going to go find the family. That is the adaptive station box, and drag it over into this model to attach to the one from one end to the other end of that line. Let me just make that transparent so we can see it better. Again, I'm showing the technology here, not necessarily the whole project file. Okay. And so what happens is if I go here to Civil 3D, select my alignment that is covering that tunnel from start to finish, the station box. And let's say you need to change for whatever reason. Let's say maybe change the direction. I'm going to do something dramatic, so it's going to be very obvious. All right. And for clarity, I'm going to temporarily turn off my corridor. I don't need to exactly worry about updating corridor. You can always update later. And I'm going to temporarily unload that 3D model reference. So when I come to the Dynamo, what will happen? I am reading information from my current document where I'm collecting the alignments information. And from that selected alignment, I am extracting the start and end station. And from those stations, I'm creating the coordinate data. Finding the coordinate data X, Y, and Z. Over here, you can see that those are written with this is all in a state plane coordinate system, which is another note. If you are working with the state plane coordinate system, you want to tell Dynamo to do the geometry scaling, so you're going to extra large. It will throw you an error, otherwise telling you that by default, it's not set up to handle such coordinates with so many, such large numbers. So that's one thing that you had to do before getting to this point. I'm going to create those two lists, and obviously with Dynamo, a couple of trials there, whether the list can go in as it is or it needs to be transposed. This is always going to be depending on what format of a file you choose. Then I'm going to write it simply to comma separated file and export the list of the 2 points, which are basically 2 sets of XYZ coordinates, not dealing with elevations right now, just for simplicity. And then this will be in the comma separated file. I'm going to run this and leave the new data of the modified alignment in the comma separated file. Over here in the Revit Dynamo, we start by reading data from that same file. I'm going to go to use the system to read the coordinates, and everything that is down this stream of controls in Dynamo is to arrive at the coordinate system and coordinate format that will be digested by Revit. So I'm just going to jump straight to the end, so that in Revit, we can first draw a line by start and end point. You can see it right here in the background, that a little thicker line. And then we're going to go to Revit and create a model curve, even though it's a line. And so that quote unquote curve has, it's one object, right? And over here, we have the coordinates for the line. So the curve is created from this line, and you can see it here in Revit. That's the curve that created. However, I haven't updated it yet. So when I click on run here to run it, it will read the information from that CSV file and update the geometry. Now that geometry is updated. Let's just change this graphics by element. Give it some transparency again. Why not? Click OK. All right, so I'm going to switch the running to automatic. And over here in Civil 3D, I'm going to switch that to run automatic. And then I'm just going to bring that alignment back to its original location. And watch how quickly that updates in Dynamo. Let's do that again. I'm going to go, okay, first of all, let's switch this off again. Don't need that. All right, and I'm going to we'll take a look at those 3D models later. So here in the 3D view, I'm just going to give it a little bit of a different viewing angle so you can see when it changes. Now the tracks are not currently created referencing that line, even though in a full-blown project, and I'll show you the details of that later on, you would have basically all the components of the Revit could be made hosted. And so when you make a change such as this one, you will see. Now, as a caveat, first of all, I do not recommend in the production environment establishing such this dynamic and instantaneous update between the two. But since we are talking about technology here and what is possible, I've set them up to work like that so you can see that instant change. Now, both scripts are running automatically and they are triggered by the change in Civil 3D. They're triggered by the change in design of that alignment, and the file is updated. In Revit script, the change is triggered by the update in the file. So the script, since it's set here to run automatically, is currently reading the data from the file. And if the file changes, this will automatically trigger the entire process and update the file. Now, on a full-blown project, you would definitely not have that automatic. However, and then you would prepare your model. This requires special quality control so that all of your components are tied to some reference that is referenced further, so it propagates, and you can reduce the time it takes to update Revit model from the modified civil alignment geometry in Civil 3D dramatically. All right, so now that we've taken a look at that, I'm going to open up a little bit of this and check out the, this one is again stripped down, but it does hold some of the elements there, the full station elements. And I'm going to first of all close the Revit Dynamo, change that, and Civil 3D. We're not going to be playing with those types of updates. So as you all know, in Civil 3D, corridors, once calculated, can be extracted to solids. And I'm going to extract solids from this corridor model using all of the regions that are there, only 3. I'm going to add that to a new drawing. And I'm going to call that track to Dynamo. And I think that is in Dynamo. Okay, so we'll just leave it there. We'll extract the solids. Now, if you open that file, shouldn't take long. And give it some wireframe shading. Take a look at the angle. You'll see clearly here where the full tunnel model is created and where the tunnel model through the station is created. So I'm going to bring this. I mean, first of all, we can attach that Revit model. That's the one. Without any specifications, this is just using the same shared coordinates. And I didn't go much in the shared coordinates concept. You can see here that all of the detail in the station as I'm moving it inside. You could use your standard project point with setting up shared coordinates and get that level of synchronization. What we're talking about here is a different level where the design can be propagated much faster from civil design to Dynamo. And now in Dynamo, naturally you will manage and insert, for example, a CAD. You can even link it. So I'm going to go to our file, and I think, no, it's in that. And then as options, you need to pay attention to control the units. I will not use origin to origin. I will use shared coordinates. And when I click open, take a look at the results. You have a little warning here. I'm going to close. And now you can see the tunnel that I created against the rest of the station. That's just your standard data coordination. Just wanted to kind of share that with you, but this isn't special. This is normal using the shared coordinates and the project point. What we've done extra today is enabled the updates to be completed. Now, of course, I've simplified everything to just show the technology and how it works. In real life, there's a lot more work to synchronize, coordinate, and achieve that information. You will be working with custom Revit families for pretty much everything. You will be working with a lot of adaptive components, which is you can call it on the edge Revit technology. But the benefits of implementing such coordination system are great. All right, I'm going to wrap up with this, and thank you for your attention, and I look forward to the questions that you might have.